Welcome everyone to the first Iceberg Summit. For our opening keynote, it is my pleasure to introduce the Chair of Apache Iceberg Project Management Committee, Ryan Blue.
All right. Hi, everyone. Welcome to the very first Apache Iceberg Summit. It's pretty amazing to be here, and this is the first one that we've done, and I'm super excited about it. I'm Ryan Blue. I'm one of the original authors and co-creators of Apache Iceberg while I was at Netflix. I'm currently the PMC chair, so I'm here to kick things off with a keynote about the community and to highlight a few things, including, first of all, some of the amazing talks that we have later today. So we have over 30 sessions across today and tomorrow. Here are some of the ones that are up today. We have both practitioner talks from the community, from companies like Tencent, Bloomberg, and Pinterest, as well as a lot of developer talks from companies like Tabular, Apple, and Netflix, covering everything from the Kafka Connect sync to table encryption and PyIceberg support, going 1.0, hopefully very soon. So stick around and check out the talks. You can find the agenda at iceberg-summit.org. And you can also use buttons on the site and within the app to add those sessions to your calendar if there are things that you want to be reminded about. I'd also love to briefly thank all of our organizers, so Tabular and Dremio, as well as the sponsors for this event. This is an absolutely amazing list of sponsors for the first Iceberg Summit, having basically some of the largest companies in the world and almost all of the largest database companies in the world on this list is a pretty amazing thing. So thank you to all of our organizers and sponsors. We could not have done an event like this without them. All right. And with that, I'm going to get started on my keynote, which is the quiet revolution. So I want to talk sort of about what is going on in the data industry, how Iceberg fits in, and also I think the theme is going to be how can Iceberg stay a successful project over the next 5 years? Because it's been, well, I guess it's been 7 years, but really like 5 years is kind of the journey until this point. So returning to this this slide of sponsors and organizers, I think it's pretty amazing to see for a project that started in late 2017. It's been maybe 6.5 years since we even started the project. And that's, first lines of code going into Git. In 2018 was when we open sourced the project, I think in November, to go from, hey, brand new project incubating in the ASF, all the way through to having sponsors from AWS and Google and all of these companies. The top streaming company, Confluent, is a real huge achievement for the community, and I think that's really incredible. It's amazing to have gotten to this point and to have brought a piece of technology from almost nothing through something that's touching almost every corner of the data ecosystem. And so the question that I've been thinking about lately is, how will the Apache Iceberg community continue to be successful and be successful in the next 5 years, not just what we've been doing up until now? Because I think that we're at an inflection point where the community has been building and building and building, and really has had a major part in changing the architecture of big data and analytic data in general. So I think that this question is really critical to where the project goes from here. And to answer it, I want to stop and think about first, well, what was important the last 5 years? You can't really plan where you're going or think about what's going to make you successful without knowing what has been successful up until this point. So that's not going to cover essentially the technical challenges or design or things like that. I've given a lot of talks on technical challenges, the design of Iceberg, and technical things. This idea of stealing all the database fundamentals and adapting them to a sort of Hadoop style architecture. But that's not what I'm going to be talking about today. Instead, I want to talk about the non-technical things. So what were the goals and what were the ideas that were important in the last 5 years? Not the technical design or any like Java conventions or things like that. Really, this is aligning the community. How has the community been aligned and working in the same direction? And I think that going all the way back to the start of this project, our goal was pretty clear: a ubiquitous table format. What we wanted, and ubiquitous really is the key word here. We wanted a table format that was everywhere. We dreamed of having a sponsor list like the one I just showed, where every one of those companies has support for Apache Iceberg. We thought at the very beginning, oh, it'd be amazing if Redshift or Snowflake or some of these, data warehouses eventually added support for Netflix's, at the time, table format. That'd be incredible. And it would be incredible because it would mean that there's a standard in place that we can all agree on, one thing that can be used everywhere. You never get your little format or the ability for something to talk to your data into a closed source commercial very valuable database without being truly ubiquitous. And so we wanted the project to be as ubiquitous as Hive, but obviously with a lot of the more modern properties, ACID transactions and all those sorts of things that were required. But that was really the original goal. And I think that that's been our goal for 5 years or 7 years or however long it's been, is that one thing that we can all agree on. And how do we get there? Well, we've gotten there through a community. And this is a neutral and inclusive community. Open source has been incredibly valuable and key to the success of a project like Iceberg. There's no way to, basically build your own thing and have it this widespread without being open source. And to build an open source project that large, the community really has to be there. And I'm incredibly happy to be a part of this amazing Apache community. I think there are two things that we also really push for in the Apache community that have made it a success. The first is neutrality. And this is one thing that Apache is really good at anyway, because the structure of the project is to have committers that have been community members and contributing to the project. Then PMC members come from that set of committers. And we make decisions largely by consensus and arguing, debating, thinking about things, coming with data, and choosing the decision that's best for the project. And everyone can participate in that process. And having everyone, that's the inclusiveness as well. So no one is in control, that's neutrality, and anyone can participate, that's inclusive. Those two things are really critical for a project like this, because it needs to be someplace that all of those companies, from AWS all the way to PuppyGraph, that they can actually go and influence and invest in, and know that it's not going to turn on a dime and do something crazy. It's something that's here for the long haul that they can really standardize on. So those two things have been incredibly important in how the community runs. And then I think there are, sort of the architectural principles, the what are we doing sort of ideas, not just the how. And I forgot I put this in. To be fair, I want to mention that, just building a great community that is neutral, that is inclusive, that anyone can adopt, doesn't necessarily solve the problem that I set up, the goal of having one ubiquitous table format. But I think it is a bit much to ask that there is one ubiquitous table format. It's perfectly fine that there are multiple table formats. The important thing is that there are good options that are widely and broadly supported. So yes, we in the end did create yet another competing standard, as my favorite XKCD shows. But I think that we've done a great job of making it so that we don't need a fourth or a fifth or a sixth standard. So I think that is one of the really good things about the community. Now, getting back to the principles and the ideas behind what we're building. I think that I would characterize this in three community principles. And I also want to point out the trade-offs of those principles, because I don't think that having a principle is really a principle unless you know what you're trading off. If you just say, oh, we're gonna make something great, well, of course it's going to be great. What are you trading off? What does that principle tell you, and how do you actually apply it? So I think it's really important to consider the trade-offs when we're also looking at these principles. So first of all, I think we value productivity. And that what I mean by that is we value human time. And in the community, we've always focused on problems that allow us to make things easier for people. This is, I think, why we've rediscovered essentially SQL tables and the SQL table abstraction, and how important that is, because that seems to have gotten it really right when it comes to making people efficient and productive. But we've always valued that productivity and what is going to make a difference for the people using this software a whole lot more than machine time or essentially like raw efficiency. Now, that's the trade-off here. You can focus on efficiency or you can focus on productivity, but I don't think you can really focus on both at the same time. So while we cannot overlook cost, I think it was a really good thing that we looked not at the features and prioritization in terms of just driving down cost. You can always do that later. What we did was really getting things right and making it easier for people to use. And I think that was a principle that was a really good call from the very beginning. The second one was to do hard things. Partial solutions and things that don't quite work are in the end going to be replaced. And I think that given the age of the project now, that was a good call. This is adding things that don't really need to be there. So schema evolution is a great example. A lot of other projects either never added schema evolution or added it, 4 years in or something like that. But valuing productivity and then getting that into the project, I think was the right call. Progress, though, requires focus. And so we can't just add everything that we want into the project. We still have to be very disciplined about what the project is focusing on. But just because some problem is hard doesn't mean that we shouldn't tackle it in this layer if it makes sense for it to be there. Because we want Iceberg to be a complete solution and to really do things that impact productivity, not just drive that cost way down. And finally, I think one of the best things that we did in the community was to all sort of write specs and agree on writing down the things that we're going to do. Careful design and simple specifications have been absolutely critical to broad adoption here. And this is, I think, it was really great to see like Google BigQuery coming through and actually implementing from the spec. Not just taking the reference implementation in Java, but actually going and re-implementing the spec, finding bugs and corner cases that we didn't write down, helping to improve the spec. But having something written, having something that says, this is how Iceberg works, is really critical to people being able to go and re-implement it from scratch and adopt and things like that. And I think that the careful design and writing everything down was critical to success. This can slow iteration, but I think that it actually has set a reasonable pace that balances the concerns of not just how do we make progress, right? That's quick iteration. We want to make progress, but also doing it in a way that doesn't leave so much technical debt that it's extremely hard to add support for the project and for the format. We can't build things and then discard them easily. So what we need to do is careful design and make sure everything is written down. And this has really paved the way, I think, to broad adoption. Everything must be simple enough for another database engine to implement, because if it's not that simple, and it's a years-long process to re-implement exactly how Iceberg does it, because there is no, central place that we wrote it down, that would be a disaster, and no one would be able to adopt the project. So I think these are the sort of concrete things that we've done in the last 5 years that have made the project successful. And those have gone, a long way. Just think back to that sponsor page and all of those database engines that that now support Iceberg. And this is, the product of what we've built there. Warehouse behavior, universal shared storage. We've really gotten there. And, looking back, I now say that Iceberg upgrades data lakes to perform and act like data warehouses. That's not really where we went here. That's not what we set out to do. We just wanted a table format that worked, and we kept adding things like schema evolution, Python support, and those sorts of things, even the new capabilities. But what we've ended up with is a format that can actually act and perform just like the storage underneath a commercial data warehouse, which is a pretty amazing place to be, and has really set us up for, I think, a surprising new era, which is why this talk is titled The Quiet Revolution. So coming back to this question that we started with, how will the Apache Iceberg community be successful in 5 years? Well, let's take a pause and really think about that aspect that I was talking about, where data architecture is today, because we had this surprise realization a couple of years ago when Snowflake and Redshift and other commercial data warehouses started adding support for Apache Iceberg. What's going on there? Why are they doing that? And let's understand today in order to answer that question. So what's happening today, I think the central trend is that projects like Apache Iceberg, I would actually include Delta in this as well, have unlocked shared data warehouse storage. And this makes broad sense because this is exactly what we set out to do, just through a different lens. So I call this a happy accident. If you go and you fix ACID transactions, different engines and different components that are able to work with the same data at the same time, concurrently, safely, that's what we set out to do. In fact, that's the core of it. ACID transactions was the first thing that we started with. But it turns out that shared warehouse storage is a much bigger area and problem, because before we never had reliable shared storage. So this is actually kicking off an unprecedented architectural shift, where any data warehouse, rather than being the storage layer and the query layer sort of glued together, very tightly coupled, we can actually decouple warehouse storage and data, and start pulling this apart. So we've never really been able to do this reliably, and that's why this is a fundamental change, and is such a big change in architecture. And we really didn't see this coming until the big commercial data warehouses started looking at this area and adding support. The bigger shift, or the biggest shift here, is that in the past, when your storage and your compute are tied together very, very closely, it turns out that most workloads are won simply by where the data lives, because you can't have another data warehouse reach into the storage of your primary data warehouse and do just one workload and write back. So you have to basically run everything through the data warehouse or system where the data resides and where the data lives. So you might choose that based on what you need for some really high value BI application, or you might choose it based on the speed and ease of ad hoc queries going to ask questions that you need answers to right away. Whatever the criteria for choosing one of these systems, the rest of the workloads just sort of come along for the ride. Because the data is there, and you don't want to maintain two copies. You don't want to sync data across regions. You're very stuck using the system where the data resides. And that is the fundamental change that Iceberg unlocks. We don't need to do that anymore. And this is awkward, right? No database really wants to give up that advantage of having, winning workloads and getting pipelines and ETL and everything, like increasing that usage based on storage. So this is sort of a groundbreaking change in the industry. And it's going to be interesting to see just how things realign. I don't know about the business models, but I do know that despite this headwind of people not really wanting to, use data that is external and centralized, despite that headwind, centralization of data is a clear trend. And I think it's a clear trend for the exact same reasons that data warehousing was important in the first place. This is essentially delivering the next step on that journey of data warehousing, where you put all of your data in one place, you maintain it, and everything can use the same thing. It's just that now we're going directly to the data instead of through a SQL layer. And when you have situations like acquisitions or other things, and you end up with two data warehouses, you actually have a clear path to combine them, rather than trying to decide, well, do we move all the tables from company A's data warehouse into company B's data warehouse, or vice versa? What do we do? Just keeping everything maintained in S3 or some other object store and bringing the engines to the data really makes a lot of sense. So I think that technologically, centralization is the biggest trend happening today. And that means that we have, I think, a realignment in how these systems are constructed. So data is becoming clearly centralized. Excuse me. As data becomes centralized, the compute components, like our sponsor Puppy Graph, can become more and more specialized because they don't have to worry about how data is being stored or garbage collection or any of the compaction operations or things like that. Engines can be really, really good at being just compute engines and focus on their problems. So we're going to see a lot of specialization unlocked in that layer because niche engines really don't need to go and implement a full security stack in order to be able to store and operate on data and things like that. So we're seeing both of these trends, both the centralization of data and other components and specialization of engines as they give up the data storage, maintenance, and security pieces of this space. So this, I think, is really where Iceberg is fitting into the ecosystem today. Iceberg is now, and this sort of puts, I think, a lot of what we're working on in the community into context. We're really working on standards for that centralized data layer. So in the last few years, we've introduced things like views. If you're going to have tables and you have this namespace of things that you can address as tables, well, that's where views live. So what we've done is we've gone and said, okay, we want to add views and a spec for views for at least any of the databases that support it. And we start small. We're starting with common views where you can store a single SQL string, and hopefully that works the same across all databases. Obviously, we know that that won't. And so we have the ability to store multiple SQL dialects and say, Trino uses this SQL blob, Spark uses this SQL blob, and we're going to have the same results coming out. And eventually we'll get to an intermediate representation that you can translate to and from. And we'll also get to, I think, materialized views and all of those other constructs that are super valuable in the warehouse space. It just makes sense for them to be part of this centralized layer. Similarly, the community has been working for the last couple of years on the REST protocol. So in the beginning, we didn't have really catalogs in the Iceberg project. We just had a very narrow interface for interacting with a single table. It's called table operations. And it's basically two methods. Give me the latest metadata and swap this metadata for this other metadata. And that allows you to commit. Everything is based on those two very, very basic primitives. You can commit, you can get the latest, and everything sort of works. But what we realized was pretty quickly, we need to manage namespaces and how do we address objects. And that really needed an interface because everyone had their own catalog implementation. Some people were using Glue, some people were using Hive, some people were like Netflix had their own Metacat, just lots of different implementations. And so we initially made it so that you could plug in your own catalog. But this really came back to bite us a couple of years ago when we started seeing that adoption from systems, Redshift, for instance. How am I going to get my catalog jar that can talk to my custom catalog into Redshift? Well, that's really never going to happen. So what we decided to do was start the REST catalog specification and make it so that we have a standard protocol for interacting with any catalog. So you can put a Hive catalog or Glue behind a REST facade, and it all sort of works with a single client and a single interaction. And again, we wanted that to be a small and easily implemented spec. Now we're seeing a lot of really great changes and enhancements to that REST protocol. Things like server-side planning, simple appends, fine-grained access control extensions, and things like that to really build out that space and make it so that we can put a lot more behind that REST protocol. We're also seeing things like the use of OAuth 2 or SIG-v4 for delegation and identity passing and things like that, as well as SCIM 2 for sync. This area has been becoming a lot more complicated, and it's great to see a lot of investment here from the community. Lastly, I think we've been seeing, just the need for better and enhanced table metadata. So the V3 table spec is probably the next big project that I'll be working on, including things like semi-structured types, improved type promotion, so you can finally promote from a long to a timestamp, as well as geotypes and transformations and Hilbert curves and things like that. We're adding more stats and histograms to Puffin files, table encryption, and we're really continuing to enhance that core table specification that we started it all. But these three areas, really, if I were to bring them together and connect that back to the idea of what's going on in the broader data architecture space, is that the project is really growing into this central data layer. Where we have protocols for interacting with a catalog, specifications for views, enhanced table metadata. All of those things are things that need to live at this central layer. OAuth 2 and SCIM are a great example of this. They're not even standards that Iceberg came up with, but applying those standards to the REST catalog spec and bringing the access controls and fine-grained access control extensions into this layer is a really important thing that the community is working on. So I think what we're building to here is really like, how do we make this centralized space and specialized set of engines work together? And to me, this is what we've been referring to as modular data architecture. We have now a whole bunch of components. Rather than having a storage layer and a SQL query layer glued together, we have potentially 3 engines or 5 engines, and some things might be done in just pure Python scripts. And so we've got to think not about just the problem of how do I build a library that interacts with one table of data, but really, how do I build data architecture that can easily plug things together? Now, I think of this as modular because everything needs to fit together like Legos. Everything should just work. You don't need to think, oh, hey, if I plug these 2 things together, do my access controls still work? That should never be a question, because people will get that wrong, and access controls are incredibly important. And everything should, continue to work. So in this modular data architecture, there are a few principles, like you control your data, everything needs to fit together. And what we're building is that centralized and shared storage that works with any specialized compute. Again, open standards are really the way forward for this. Both tables and views, the catalog protocol for interacting with however you want to store your data, track your data, and building on what we've done on the technical side, we want to have declarative patterns and services for automation and things like that. So when I go back and we finally answer that question of what's going to make Iceberg successful in the next 5 years, I think of it as really changing, I think, this first goal from what is the goal of the community today? Well, it's no longer really a table format. I think that the goal and sort of what ties the community together today is that we're building ubiquitous standards, both a table format and a view format and other things. And those standards all support this idea of modular data architecture, and specifically the centralized data layer of that modular architecture. Now, we will still be figuring out what exactly this means over the next 5 years. This space is rapidly changing and really not something that I think I can define today. But I think this is my best guess. We're building a bunch of standards to make things pluggable, to make them work together, and to really be able to build data architecture with that centralized data layer and many different specialized compute layers. The how is unchanged. We still need to build a neutral and inclusive open source community in order to invest in building support for these standards and building on top of this central, data and compute layer. Sorry, not compute. Building on this central data and policy and centralized layer for data architecture. We still need to be very neutral and inclusive. Everyone needs to be able to have a voice in this community and know that everyone participates equally. That's critical to ensuring that we have adoption broadly across the ecosystem. And coming back to our community principles, I would say that most of these are largely unchanged, but I am going to add to them. So first of all, valuing productivity and really trying to do things that make a difference for people, to make people more efficient, more effective. I think that's still the North Star. We will, of course, always make things better and faster. That's kind of unavoidable, but I think really going to make people productive is the best high level goal. Do hard things. Of course, we'll continue to do that. I'd love to double down though on writing specifications, because careful and simple are absolutely more important than ever, especially as we have more specifications and more requirements. The complexity of this area is growing and growing. And we always need to be mindful that we're trying to keep it as simple as possible. Even with fine-grained access controls, we need ways to have them, fall back to coarse-grained. No, like, hey, if you're coming from a Python process, I don't trust that you're going to implement my fine-grained access controls. So simply deny access, and that's okay. That's a good access control policy. Making sure that we have the ability for simpler components to connect and be successful, and especially keeping it so that the requirements of adding Iceberg support are not so onerous that no one ever does it. Those things are really, really important. And this is especially important with, through the lens of the Python and Rust and Go implementations that the community is working to build. Those are going to be critical for working with Iceberg in the future, as people use those language implementations and don't have to re-implement everything themselves. However, someone has to maintain them, and making sure that our specs are simple, not overly complex, and are well designed and carefully done is more important than ever. Now, the next one is really, what are the challenges of this new goal? And I think probably the biggest challenge of being where we're at today is that the community has grown, an incredible amount in the last couple of years. The community has really, really scaled up, and I think we're growing at something like 40% over 3 months, or some ridiculous thing. We're seeing new implementations and support popping up all over the place. And so the question becomes, how do we keep this community, the neutral and inclusive community, operating and really able to put out good work at this new scale? I think one idea is that we're transitioning from just a community of developers to a community of also users. And, that matters a lot. So, please help out. Help others find ways to meet their needs. That is a really core thing in an open source community. Just participating, being there, and helping others, understanding their problems, because it probably provides you a better understanding of your own. I think that we also need to continue to make sure that we are communicating effectively. Be honest and open about what you need and why you're working on something, so that other people can understand and say, oh, hey, that's a good idea. If you're sort of closed off and you're just like, oh, I just need this one thing, don't worry about it, I just need this one thing. People don't listen and you're never going to get it reviewed. Just talk about it and try and give other people a reason to help you out. Just like you need to help out other people. And the last one is to assume good intent. And if you're building protocols, there's always that saying, be liberal with what you accept and careful about what you produce. And I think that goes for communities and interpersonal interaction as well. Assume that other people just want to get their job done. They're not trying to hurt the community by taking advantage and asking dumb questions. They just need some help. Assume everyone is there for a good reason. I think that is always a good rule in open source communities. And this is important because the community is growing so rapidly right now. It's really amazing to see all of the new people. And I really hope that everyone finds that this is a community that they love working in and is really helpful and a great place to learn and spend their time. And so thank you, everyone. I know that was largely non-technical, but I think it's really important to consider what has made the community successful in the past and where we're headed. Thank you all for being a part of the very first Iceberg Summit. I'm really looking forward to hearing all of the talks later today that are going to, address and help us all learn more about different areas of Iceberg, how Iceberg has been used at large organizations. The practitioner talks are very exciting. And I'm also really excited to learn a whole lot more about some of these other areas. By the way, the other areas, if we go back to this slide, we have talks on the REST catalog extensions, server-side planning and appends. We have talks on views. We have talks on table encryption and, stats and all of the things on here. So check out the developer talks for some very interesting content on that.